Hello guys, in this video tutorial I would like to give an overview of the course Statistic 1 with the course code STAT-104 for NUST Business School NUST. So in this course I will give an overview about each, not chapter wise but topic wise, like description of data. So description of data can be done in two ways, numerically and graphically, and similarly I will do some overview about measurement scales, probability, different rules of probability, probability distribution, and sampling. So let's move to the formal lecture that how we can do this. The first thing is introduction. Introduction mean what is statistics? Statistic is the art, is the science of drawing information from the data. Or statistic is simply, you can say it is, in statistic we just collect, tabulate, and analyze the data and reaching to some conclusion. So it is a collection, tabulation, and analysis of the data. And there are two types of statistics. So statistic, that is the definition of statistic, and now there are two types of statistics. One is descriptive statistic and the other is inferential statistic. Descriptive statistic and inferential statistic. In descriptive statistic, we summarize the data which we have. Only we just summarize the data. We don't need to draw some conclusion about the bigger data set like the population data set. So we just analyze the data. In inferential statistic, we analyze the small portion of the data, that we can say sample data, and we draw conclusion about the population. So this is the difference between descriptive statistic and inferential statistic. Now there are two other terms which I need to explain first, but anyway, sample and population. Sample, first we need to define population and then sample. Population is the total number of items of interest. The total number of item of interest. The total number of items of interest. This means that suppose you are interested in the height, to know about the average height of the men in Pakistan, then the total number of men in Pakistan is your population. If you are interested in the average CGPA of BE student of business, tourism and hospitality department, then the total number of students who study this in this department like tourism and hospitality management in Pakistan is your population. Sample is the small portion or a sub part of the population. So whatever is your population, maybe your population is the number of men, about you, the average height you are interested, so then a specific number of people of men is your population. And if you have another population like the number of students of tourism and hospitality management, then you can choose some specific number of students from this population, that is sample. So a part of the population is called sample. There may be other definition as well. Now, parameter and statistic. Parameter and statistic. These are the numerical quantities calculated for population data. The numerical quantities you can calculate from population data is called parameter, and the numerical quantity is calculated per sample data is called statistic. This is the difference. Now let's move to the measurement scale. There are four measurement scales. Measurement scales. There are four measurement of scales. Number one is nominal. Number two is ordinal. Third is interval scale, and fourth is ratio scale. Now I can let's define this from my slides, because I don't want to write such type of things in detail on. So let's see how these things are. There are some properties, or you can say there are some there are some properties of these scales. The one is identity. Each value on measurement scale has a unique meaning, so this scale will use these properties. Magnitude, the value of measurement scale have an order relationship to one another. That is, some values are larger and some are smaller. Equal interval, scale units along the scale are equal to one another. This means that, for example, the difference between 1 and 2 would be equal to the difference between 19 and 20. A minimum value of 0. The scale has a true 0 point value which no value exists. So these scale will satisfy some of these properties, and the scale which satisfy maximum properties, we can say that is the highest level scale. So nominal scale. For the nominal level of measurement, observation of a qualitative variable can only be classified and counted. There is no particular order of the labels. The classification of the 6 colors of M&M milk chocolate candies is an example of the nominal level of measurement. When simply classify the candies by color, there is no natural order. There is no order. You can just classify by color. So you can read the slide further, but there is nothing, no information further. Only you can classify by the color. Ordinal level scale is the highest, is the next higher level of data is the ordinal level. Okay, this table is not here, so I will not explain this, but let's see. Table 1 to 2 lists the student rating. Okay, the student rating, you can see we don't have the table, but we can understand the message. List the student rating the Professor James Brunier and an introduction to finance course. Each student in the class answered a question. Overall, how did you rate the instructor in this class? The variable rating illustrates the use of the ordinal scale of measurement. One classification is higher or better than the next one, that is, superior is better than good, good is better than average, and so on. However, we are not able to distinguish the magnitude of the difference between the groups. So this means that good is better than average, superior is better than good, but we don't know how much. So this is the difference. Okay, so you can see the full slide for this, because this is an overview, so I will just try to be precise. The next scale is interval scale. The interval level of measurement is the next level, highest level. It includes all the characteristics of the ordinal level, but in addition, the difference between the value is a constant size. An example of the interval level of measurement is the temperature. Suppose the higher temperature on 3 consecutive winter days in Western are 28, 31 and 20 degrees Fahrenheit. These temperature can be easily ranked, but we can also determine the difference between temperature. This is possible because 1 degree Fahrenheit represent a constant unit of measurement. Equal differences between two temperatures are the same regardless of their position on the scale. That is, the difference between 10 degree Fahrenheit and 15 degree Fahrenheit is 5. The difference between 50 and 55 degree is also 5 degree Fahrenheit. The next and the highest level uh, measurement of scale is ratio level data. These satisfy all the properties of the previous scale, but these also include a value of 0, a minimum value of 0. So this is the highest level scale. Okay, so this is about the scales. Now you can read the slide for detail. Now let's move to the describing data. 3. Describing data. So describing data, you can do it in two ways. One is numerically and the other is graphically. Numerically, you can do this by mean, average, or you can say mean, median. This is median, and the third is mode. I would like to explain this mean as you can denote this by x bar, and this is equal to summation xi divided by n. This is for sample data. For population data, you can say that is denoted by mu. Median, you can say for odd observation, this is the middle value. Simply you can say middle value, but you need to arrange the data, remember, in ascending or descending order, whatever. So that, and for all data, it is the middle value of the data after arranging the data, and for even observation, it is the average of the two middle values after arranging the data. And mode is the most frequent value, the value which is repeated most of the time in the data, that is called mode. So you can use these. You can use other quantity as well, but these are the topmost and the part of the course. Graphically, you can explain data by bar plot. So a lot of types. Frequency, you can add frequency table here, but frequency I will include frequency polygon. Frequency polygon, pie chart or pie graph, and many others. You can do many graphs, but these are the you can say histogram as well. Histogram. So you can describe the data numerically as well as graphically by using different techniques. These are a few ones. There are much more. Now you can define data numerically by using these means, but there is another thing that is called, that is also a part of this numerical, that is called variation in the data. So you can do variation of the data. You can say how to measure the variation of the data. You can do this by a range, the first one. That is the difference between highest and smallest value. This is equal to, you can say R range is equal to highest value minus lowest value. Simply you can say R is equal to X maximum value or X minimum value, you can say. So either up, you can write max, you can write minimum. Okay? And now variance and standard deviation. Remember, this is very important because if two data sets have the same mean value, then you need to go to the variation. You need to calculate the variation, and of course The data which have less variation, we can say this data is better if the mean values are same. So this means that now variance, अगर आप if you talk about population variance, this is equal to sigma square summation xi minus mu whole square divided by n, where x is the data, mu is the mean of that data, and n is the population size. Sample variance, that is equal to s square summation xi minus x bar whole square divided by n minus 1. So this means this is the variable, this is the mean of this variable, and this is the sample size minus 1. So you can, of course, when the mean values are same, then you cannot decide which data is better, then you need to move to the variance. And the data which have less variance, we can say that data is better. Okay, so this was the description of the data. Now we need to probability. This is, I think, the fourth one or whatever. Let's see. I think this is fourth one, yes. Probability. Probability means if you are interested in an event, to calculate the probability of an event, the simple formula, probability. Probability of event A, suppose you are interested, mean the number of favorable chances divided by the total number of chances. Simple, that formula. Now there are some rule of probability. I will move to those rule of the probability. The first one, remember that probability of an event, suppose event A, this should lie 0 and 1. Remember. Now the first one, rules of probability. Rules of probability. The first one is additive rule. Additive rules of probability. I would like to tell you something about these rules, so to differentiate between applying different rules. In additive rules, you can apply additive rules when there is a statement that calculate the probability of event A or B, or calculate the probability of the occurrence of either event A or B. So if you see either or you see or in the statement, you can use the additive rules of probability. So this means that if you are asked that calculate the probability of event A or B, or calculate the probability of either event A or B, then you can use this rule. This is called the additive rule of probability. This is equal to probability of A plus probability of B minus probability of A intersection B. This is when the events are not mutually exclusive. When the events A and B are not mutually exclusive. When the events are mutually exclusive, then this equal to probability of A plus probability of B, because this part is now not exist, because there is no common point. The events are mutually exclusive. Now, conventional probability. I have separate video, I will upload that as well for on the conditional probability, so you can see that for detail. Conditional probability mean that if you are interested in an event which depend on other event which is already occurred, so you can say that is called conditional probability. Suppose you are interested to find the probability of event A, given that an event B already occurred. So this is denoted by probability of A given B, and we can say probability of A given B. See, multiplicative rule. Multiplicative rules of probability. Multiplicative rules of probability is, suppose I need to calculate. Remember, in multiplicative rule you will see these words in the statement of the problem. Calculate the probability of event A and event B, or calculate the probability of both event A and B. So if you see these words, for sure this is the case of multiplicative rules of probability. Probability of event A and B, or probability of both event A and B. This is equal to probability of A and to probability of B given A. And remember that if these two events are independent, you can see that if these two events are independent, then what is equal to this? This is then equal to B given A is equal to probability of B, because this does not depend on A, then this is equal to this one. And in that case, probability of A intersection B is equal to probability of A into probability of B. So this is in case of independent, and this is not independent. These are in case of dependent. So you can calculate conditional probability. You can calculate the probability of both event by using this formula, the probability of event A and the probability of event B given A occurred. And if the events are independent, then this is the probability of event A and B is just equal to the product of the individual probabilities of A and B. Now the total law of probability. Total law of probability. This is important, and I will not in this part I would like to explain the difference between the law of total probability and Bayes theorem. You will see there is a clear difference between total law of probability and Bayes rules. You can see this diagram, that a sample space is partition into different events, that is B1, B2, B3 and so on, and in the center there is an event A which is also partitioned, by the way. This is B1, B2, B3, B4, B5 and so on. So this event is partition. Now by rules you can see, now I need A. So how I can write A for this diagram? You can say in that case A is equal to B1 intersection A. You can see from here. I would like to show you that again. This means that this part is only this part, this blue part here in B1 is B1 intersection A. B2 intersection A is empty, so of course the probability will 0, so will not included. B3, this blue part here is B3 intersection A. This part is B4 intersection A and so on. So A is equal to, you can write A is equal to this one, and then union B2 intersection A union, we can write union BK intersection A. Now if you apply the probability, then this is equal to probability B1 intersection A. This now become plus probability, okay, no, I will not convert this now to plus. You can just, still this is union because the probability outside, so I will say, I will do one more step, A union A, BK intersection A. So now this is equal to probability of B1 intersection A. Now it's converted to plus probability of B2 intersection A plus probability of BK intersection A. So this is, now you can say this is the probability. Again you can, now you can write this is the sum of probability of this is equal to I from 1 to K, or probability of B1 intersection A. So BI, not B1. So this is now equivalent to this rules. This is equivalent to this one. So you already proved the theorem. You can now expand this like this: probability of BI and probability of A given BI. Now you can write in the next step, probability of A is equal to I from 1 to K BI and probability of A given BI. Now, okay, this is the total law of probability. Now, what was asked actually? This, I will use this diagram for Bayes theorem, but in the total law of probability, you are asked to calculate the probability of A. Remember, in the total law of probability, we need to calculate the probability of A. In Bayes theorem, you need to calculate any of these BIs. This is the difference, remember. In the total law of probability, you need to calculate the probability of A, but in the Bayes theorem, you need to calculate the probability of any of these BIs given that A occurred. You will see this in the Bayes theorem. So this was the total law of probability. I hope this is explained. This is now the final shape which I did. This is the little proof which I did. Okay. Now Bayes rule. Remember that I already told you that in the Bayes rule, you need to calculate the probability for, in that diagram, for any BI, B1, B2 or whatever. So if you see this, you can see this, suppose this is B1. Suppose this is B1. I will just explain in that way. Now Bayes rule. This is the last in probability. E Bayes rule. In Bayes rule, you need to calculate the probability of, suppose, B1. Generally, you can say B2, B3, whatever, given that A already occurred. This means that this is equal to probability of B1 intersection A. Multiplicative rule you can write like this, in probability of A. Remember, what is probability of A? And if you are using their diagram, probability of A is equal to this one. Simply, you can say like this. This is also probability of A, and this is also. So in the next step, you can write probability of B1 intersection A divided by probability summation I from 1 to K summation I from 1 to K probability of BI intersection A. And further, if you want to expand this further, you can see this shape of the Bayes rules. That is equal to probability of B1, probability of A given B1. This is equal to probability of B1, probability of A given B1, and the denominator, it will be the sum. You can say I from 1 to k, probability of Bi, probability of A given Bi. So this is now the Bayes rule. Remember that this part is a simple part of this one. This is the summation for all the Bi's, and this is the only one. So if you are asked to calculate the probability of A for such type of, in such type of situation, then that is the total law probability. If you are asked to calculate for one of the, of the machine or whatever, for one person or whatever, then that is the case of Bayes rule. So this is the difference. So I will stop this here, and now the next is probability distribution. Probability distribution. Probability distribution. There are two types of probability distribution in this course: discrete and continuous. Discrete means which, if the random variable is discrete, then we say this variable follow discrete distribution, and if the random variable is continuous, then we say it follow continuous distribution. In your course, there are two types of discrete distribution and two types continuous distribution. So let me explain this: discrete distribution and continuous distribution. In discrete distribution, there are two distributions. One is binomial and the other is Poisson. I have a complete video on binomial distribution, almost 47 minutes, so you can see that. I will share the links below this video. In continuous distribution, you have two distributions. One is uniform and the other is normal. So in binomial distribution, remember one point I will explain. One point you have a lecture, so you can see that lecture. In binomial distribution, each trial or each outcome has two possible outcomes. Each trial has two possible outcomes. Like with coin toss, there is possibility of head or tail. When a student give an exam, he or she may be pass or fail. So there are two possibilities of each trial. So that is in case of binomial distribution. So you can use, if so you have such type of problem, you can use binomial distribution. Poisson is a different case. Poisson is normally related to counting. This means that number of car entering to nest, number of patient entering to hospital, number of patient, number of customer entering to cinema or superstore. That is Poisson, and these two are discrete distribution. Uniform, I will write the function as well. The function as x equal to x as ncx p power x q power n minus x. X is equal to 0, 1, 2 up to n. Or the function for this e power minus mu power x factorial 1 to infinity. Uniform distribution is uniform distribution which have uniform, the density is uniform. Like suppose this if a variable is uniform between limits a and b, then f of x is equal to 1 divided by b minus a. X lies between a and b. Normal distribution I will write below because the space may be less. So for normal distribution, the density function is 1 divided by 2 pi sigma e power minus 1 divided 2 sigma square to x minus mu whole square. X lies between minus infinity, infinity, minus infinity, infinity, sigma square greater than 0. So you can use in different situation, different distribution. I already discussed these in the lectures. Standard normal distribution. This is another thing. Standard normal distribution. Normal distribution. If suppose I have variable z and that is standardized, mean that variable minus mean divided by standard deviation, that is called standard normal distribution. This is distribution standard normal with zero mean and unit variance. You don't need to prove mean zero and variance. You can prove this in 1 minute, but I'm not interested in this. And now the last topic, that is sampling. I think this can be the 6th topic. Yes, sampling. Some student requested sampling is important. Sampling. Already I told you that there are two things in statistics normally we used: population and sample. So sampling is the procedure of drawing sample, and sample means sample, which of your observation. You cannot avoid sampling because sometime you have to do some experiment like testing some important thing. You don't need to destroy all the thing, test all the thing and then draw conclusion. In that case, sampling is mandatory. You need to do some few things and then you can say, okay, we achieved the parameter of this. This process, whatever are the products. So sometimes this is really important and mandatory. I will explain this from my slides. Okay, reason to sample. These are some reasons to sample. Why we need sample? The time to contact the whole population may be prohibitive. So one is the reason. You can read the details. And the cost of studying all the items in a population may be prohibitive. This is also, you can read the detail. I will not. The physical impossibility checking all items in the population. This is, I already told you sometime. If you cook the foods and you don't need to eat all, and then you can say, oh, the salt was okay, the food was cooked well, but instead you check a little portion and then you say, oh, it's nice food with the, all the things are appropriate. The destructive nature of some test, yeah, this is important. And the sample result are adequate. Sometimes you don't need to do all. If you have a lot of many items of population that required a lot of stuffs, a lot of times, energy, and then at the end you say, oh, the result just close to the sample. Why I waste my time and resources and this. So sometimes this is also one of the reason. There in this course we will discuss 3 types of sampling. Simple random sampling is the first, which is very important, and you can see everywhere this is used. The most widely used types of sampling is a simple random sample. We can say the definition: a sample selected so that each item or person in the population has the same chances of being included. So this means that each item has the same probability to be chosen in the sample. Systematic random sampling. This is another type of sampling. In simple random sampling, procedure may be awkward in some research situation. For example, suppose the sales division of the computer printer unlimited needs to quickly estimate the mean dollar revenue per sale during the past month. To find that 2,000 sale invoices were recorded and stored in the file drawers, and decide to select 100 invoices to estimate the mean dollar revenue. This means that 2,000 are the total, so we need 100. We need to draw 100 from this 2,000. Simple random sampling requires the numbering of each invoice before using the random number table to select the 100 invoice. One thing, remember that you need in simple random sampling to label each item. So this is one of the drawbacks, because if you have a huge number of population, then this is really difficult. Okay, simple random sampling require the numbering of each invoice before using random number to be select from 100 invoice. The numbering process would be very time consuming task. Instead, systematic random sample can be used. So what is the systematic random sample? A random start point is selected. A random point is selected, suppose whatever is the value, and then every kth number of population is selected. Initially you need to select one number, one initially starting point, and then every kth element of the population can be selected. Suppose this is now the detail. First, k is calculated. What is the kth which we said? First, k is calculated as the population size divided by the sample size. So k is equal to population size divided by sample size. For computer printer limited, we would select every 12th invoice from the file drawers. Okay, k is 20. So we will select 20th invoice from the file drawers. And so doing, the numbering process is avoided. If k is not the whole number, it can be rounded down. Okay. Random sampling is used in the selection of the first invoice. So this is 20th. Okay, this is 20. The value is 20 for k. Now random sampling is used in the selection of the first invoice. We need to use random sampling for the first invoice. For example, a number from random number table is between 1 and k or 20. Remember, this should be between 1 and 20. It should not be higher than 20, which is the value of k. Would be selected. Say the random number was 18. Let's suppose that is 18. Then the starting with the 18th, the first one that was randomly selected is 18th plus 20, that is 38, plus 20, 58, etc. would be selected as the sample. So this is the procedure for systematic random sampling. And now the last one, stratified random sampling. Simple random sampling is normally used when the population units are homogeneous, and similarly you can say systematic random sampling. But when the population units are heterogeneous, then we need to use stratified random sampling. We need to make homogeneous group first from the elements of the population, and then we need to draw sample from each stratum. When the population can be clearly divided into groups based on some characteristic, stratified random sampling can be used to guarantee each group is represented in the sample. This is true. The group are also called strata. For example, college student can be grouped as a full-time or part-time male or female, and or traditional or non-traditional. Once the strata are defined, then we can apply simple random sampling within each group or strata. So we need to divide the population into homogeneous groups, and then we need to use simple random sampling in each group to draw the sample. A population is divided into subgroups called stratas, and sample is randomly selected from each stratum. This is just simple definition. This type of sampling can be used when the population has heterogeneous units. So this is some reason of this. So I think I completed. There are 3 sampling schemes: simple random sampling, systematic random sampling, and the third one is stratified sampling. With this, the overview of the course is completed. I hope this will help you. If you like the content of the lecture, please subscribe the channel. Thank you very much, and see you in the next video. Ciao.